Okay, these are the notes for Wednesday, November 16th, section 6465, proving that triangles are similar using three methods: angle, angle, side, 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 and side, angle, side. Very similar to when we worked on triangle congruence and the 5 methods to prove that two triangles are congruent to one another. Remember that similar figures, or to be similar, means that the corresponding sides are proportional and that the corresponding angles are congruent. So keep that in mind as we work through here. The first method we have to prove that two triangles are similar to one another is by angle, angle. So if we can identify two angles in a triangle that are congruent to two angles in another, we know those two triangles are similar to one another. So when I look at the first example here, I know that in every triangle we have 180 degrees in the interior. Both these are right, so the two remaining need to add up to 90. So 90 less 53 is going to end up being 37. So angle Z here is 37, and we see this one's also 37, so this must be 53. So the two triangles are congruent by angle, angle. We've identified two angles in this that are congruent to two angles in the other. So to write the similarity statement, I would say triangle ABC, A to B to C, 53 to 90 to 37, is similar to triangle 53, 90, 37, XYZ. We list them again in the corresponding order so that I know which parts relate to which. Looking at the practice down below, I have two triangles, FGH and QRS, with all congruent angles. I know that that makes them equiangular as well as equilateral. And if they're all equiangular, and the sum of the interior angles is 180, and the three equal, then they all must be 60. And so I know again that I have two triangles in this that are congruent to at least two in this, so the two triangles are similar. So I can say triangle FGH is similar to triangle RQS by the angle-angle similarity postulate. And over on this one, I have two right triangles. I know that if this intersects there at 90 degrees, that the angle on the other side is also 90 degrees. So if I orient them in the same position, this would then be F, E, D. This would be the 58. And I know that this is 32, 90, that this one must also be 58, and this would be 32. So I see the corresponding parts. And I know that these two triangles, CDF, is similar to triangle DEF. Again, I have two angles corresponding to two in another, so that's by angle, angle. And that's the similarity postulate for when we begin to do proofs with these. A couple more examples here. They get a little bit more abstract. Again, I have two triangles shown here, and I see that they have two congruent angles here, and certainly I know that this angle is going to be congruent to itself. So I have angle Q is congruent to angle Q, because it's part of both triangles, the smaller QPR and then the larger QST. And I also have angle R here is congruent to angle T. So because I've identified two angles in a triangle congruent to two angles in another, I know the two triangles are similar. So I could write triangle PQR is similar to triangle SQR by the angle-angle similarity postulate. Over on the second set here, a couple things going on. These arrows again mean that segment EG is parallel to HJ, so I have some alternate interior angles here that are congruent. I can do the same thing over here at E and J, and I also know that I have vertical angles created here. So I have angle G is congruent to angle H. E would be to J. I've chosen to use the vertical. Really, you should use the 3 to name these. EFG is congruent to angle. I started here, EFG, so that would be JFH. So the 2 triangles, say EFG, is similar to triangle JFH by the angle-angle similarity postulate. Now the practice here says if EG was not parallel to HJ, so if these 2 were not known to be parallel, would the 2 or could the 2 triangles still be similar? All we would know at that point then is that we have congruent vertical angles. If these lines are not parallel, then I do not know, or I'm not able to prove, that these are alternate interior or that they have any relationship to one another. So on this, I would say no. Because if these angles were to be congruent, then we would have some of our converse theorems with the parallel lines cut by transversal, and because they are congruent, EG would have to be parallel to HJ. So if they are not or cannot be parallel, then these could not be similar triangles. And in the example 3, a school building. Best thing to do here is to begin to draw a picture. Cast a shadow. Shadows fall on the ground. So that's the length here of 26 feet. This should just be long, not tall and long. At the same time, a student standing nearby who reaches 71 inches tall. And that 71 inches I'm going to go ahead and convert to feet, and we're going to call that 5.9 or 5.92 feet. And he casts a shadow 48 inches long, and that 48 inches we know is just 4 feet. We're looking for how tall or the height of the building. So what we've done is we've created 2 similar triangles, and we can estimate or find the height of the building by setting up a proportion here. So I compare the corresponding parts. That would be the student's height to the building's height, the length of the shadow to the length of the shadow. It doesn't matter where you start as long as you maintain the proportion. So if we say x, the height of the building, is to the student's height, as the length of the building's shadow is to the student's shadow. And notice again here that I've got my building, the height and shadow on top, and then we've got the student, height and shadow on the bottom. So when I cross multiply, I get 4x is equal to approximately 153.92. Then we divide both sides by 4, and x is equal to 38.48. So the best answer there would be C. Same thing in the practice here down below. You set up a similar picture. We have a 6-foot-tall man who casts a shadow, 6 feet tall, his shadow, and then we have a small child who will also cast a shadow, and 6 feet tall, 54 inches, that's 4.5 feet. I've just made the conversion here. And then I have a child who's 58, that's approximately 4.83. And his shadow is what we're looking for, that's the x. So again, just need to make sure that I'm comparing corresponding parts. Height to height, shadow to shadow. Doesn't matter where you start. So we can put x on top. His shadow is to the adult shadow, as the child's height is to the adult's height. We cross multiply and solve. I've got 6x, 4.5 times 4.83 is about 21.7. and then divide both sides by 6, and x is equal to approximately 3.6 feet. Another means of proving that two triangles are similar is by side-side-side similarity theorem. And this one basically states that if I can show that three sides of a triangle are proportional to the three sides of a second, then the two triangles must be similar. So we do that by comparing the corresponding parts. This is what that has to do. The side lengths are proportional if the shapes are similar. So if we begin to look here to see which of these could be similar to one another, let's compare XYZ to STU. So because they're not oriented in the same position, or I'm not sure how they are, compare, this is the longest side here, so I would compare it to the longest side there. This is the shortest, so I would compare it to the shortest. This is the middle side, so I compare it to the middle. And I just set up those ratios. So I have 30 over 30, longest sides, that's a 1 to 1. I have 25 to 20. So right there I know that those two are not similar. 30 over 30 is 1, 25 over 20 is 5/4. So these two are not similar to one another. Now if I set it up to compare, let's take XYZ to this one, PQR, I again compare the corresponding parts. 30 was the largest, so I'll compare it to the largest here. I had the middle, which goes there, and the shortest side, 15 and 21. And I compare those corresponding parts again. 42 over 30 is equal to 35 over 25 is equal to 21 over 15. And again, when you reduce all of these, you'll see that they are all 7/5. And so these two triangles, XYZ, is similar to triangle PQR. Again, notice that when you set up your ratios here to compare, that you have all of the sides, this is from PQR, on top, all of XYZ on the bottom. It doesn't matter if that's flipped, that would just be 5 over 7, still proportional. Over in example 5, we need to find the value of x, so I just need to compare corresponding parts. XY to Z, PQR, so I know that XY corresponds to PQ. And I know YZ corresponds to QR. So 20 is to 30 as x plus 6 is to 21. We cross multiply and solve. So what you have to remember here is you need to distribute. That becomes 30x plus 180 equals 20 times 21, which is 420. And then we rearrange. So 30x equals 240. Divide both sides by 30. And the value of x is 8. I can then substitute and know this side's 14, and this side would be 18. Practice number 5. We're trying to identify which of the triangles are similar. And again, we just compare the corresponding parts. As I look at this shape, here's the largest side, so I'm going to compare it to the largest side to the largest side. And then I have the shortest side, goes to the shortest side, to the shortest side, and then the middle, middle, and middle. And then I can begin to compare. So if I have short side is to the short side, as middle, 24 is to 30, as long, 26 is to 33. And then you can just reduce all these, and you can do that in your calculator, hit math, enter, enter. 20 over 24, what goes into both? We have 4, so this would reduce to 5/6. 24 over 30, what goes into both of those? 6 does, and that would go into 4/5. And so we see that these two are already not equal, so these two triangles are not similar. So let's compare the first and the third. So I have We'll just start largest side this time. 26 is to 39, as 24 is to 36, as 20 is to 30. And when we reduce all these, you'll find the same ratio, 26 and 39. Let's see, 2 will go into both those. That would be, no, 2 won't go into both of those. 26 and 39. Ends up being 0.66, it's 2/3. 24 into 36, when you reduce that down, is also 2/3, and 20 over 30 is 2 over 3, also 2/3. So we see that those two are equal. So I do have triangle LMN is similar to triangle YZX. Again, make sure you're labeling the corresponding parts. LM, L to M is the shortest side. It corresponds to YZ. Y to Z, the shortest side here. And the final method we have to prove that two triangles are similar is side angle side. If I can show that two sides are proportional to two sides of another triangle and the included angle, that's the angle between them, is congruent, then I know that the two triangles are similar. Scroll up here for the first practice. If I have an enlargement here of triangle XYW to JHK, are they similar? Well, if I look at them, compare the corresponding parts, and I see that the angle here, that's the included angle, is congruent, so I've got that part. So is 27 to 18 the same as I have 24 to 16? So when I reduce these down, 9 goes into both, that's 3/2. In here, 8 goes into both, that's 3/2. So they are indeed proportional. So those two triangles, XYW, is similar to JHK. And that is by side angle side. And that is the similarity theorem. And last couple practice here. What method can we use? Well, when I see all I have is three shapes, I'm looking at probably side, 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 so I need to compare the corresponding. So I have shortest side here, goes to the shortest side here, longest, compare the longest, and middle to middle. And we just set up those ratios. 32 over 24, 20 to 15, 16 to 12. And when we reduce all these, 32, 24, 8 goes into both those, and that would reduce to 4/3. 5 goes into both these, 4/3. 4 goes into both those, 4/3. Since they are proportional, I know that those triangles are similar by the side, side, side similarity theorem. And these last two, SRT and PNQ, I see the angles are congruent at R and N. They're both 90 degrees, and then I have side measurements on either side of them, so I'm looking side angle side, and I'm going to compare the largest, or excuse me, the smallest rather, to the smallest, and the larger side to the larger side given. The hypotenuse would be the largest side. And 24 is to 18, and 28 is to 21. You reduce these down, and we know 6 goes into both. This again would be 4/3. 7 goes into both, 4/3. They are indeed proportional, so these are similar by side angle side similarity theorem.